Hello everybody and welcome to this tutorial. So I'm really excited about this tutorial and I'm going to start by explaining exactly what we're going to be making. So this of course is going to be a Java tutorial and I really wanted to make a real application. So this idea when you learn Java you do toy examples, so you might make a shopping cart, add items, have a scanner, and these examples are fantastic for learning the language. However, at some point we need to bridge that into something a bit more real world. So we're going to be making a to-do list application called YATL, yet another to-do list. And this is going to be part one in a two-part series. The first part, we are going to make the application, or at least the back end to the application. I'll explain more about that in a minute. In the second part, we are going to test it. Along the way, we are going to use good software architecture, good object-oriented design, and we're really going to try and bring together all of your programming knowledge so far in this real-world application. So I'll just explain what we're going to be doing. So we're going to be creating a simple API. We're actually more specifically creating a RESTful programming, a RESTful API, RESTful programming, RESTful API. I'm going to show you what it will look like so you can access it through a web browser. And it looks like this. So if I visit localhost to 8000, obviously normally this would be deployed over the web. We get a JSON list of to-dos. These are being pulled from a SQLite database. Now, JSON format is very easy to utilize in other applications. So in the real world, how this would work is you might be a back-end programmer. You would create a RESTful API that returns JSON, and then a front-end application such as a mobile app or a web application or even a desktop application would interact with your API. And it just uses HTTP to facilitate that interaction. So it's a very simple way for applications to communicate with each other. Let's see what else we could do. So we can go to, if we do /1, that's going to pull up the to-do with the ID of 1. And our application is managing all of this. So we get ID 1, learn Java, and you can see we have this done field here, which is currently false. And then we can do things like this. We can add parameters where you can say status equals completed, and Ace Joe's module. You can see that's already been completed. So you can keep building out this functionality, and you can have a pretty sophisticated window into a database. So this is a very normal, very mainstream way of exposing functionality and allowing other applications to use this functionality. So when we visit any of these URLs, the browser is issuing a GET request, and that is a typical request that we use to pull data out of a RESTful API. We're not going to be doing update, so we're not actually going to be updating data, but you can also update data through an API as well. So definitely look more into REST. So let's just go over some of the details of what we'll be doing. We'll be using SQLite to store the database. So SQLite is a SQL database and it allows us to use either an in-memory database, which we'll use for testing, or we can use a file database. So it's just a flat file that sits in our application and we use it to store all the data. Very useful. If you're creating a mobile application, for instance, and you want local storage, SQLite is a really good option. We're going to be using the package manager Maven to pull in dependencies to allow us to do all of this. So we need to understand the Maven project structure. And we're going to be creating a model view controller application. So this is an architectural pattern where you have a model, view, and controller. The model is going to hold a representation of a to-do item. The controller is going to handle HTTP requests and pass back the view, which in this case is just going to be JSON, our JSON lists that look like this, right? In order to connect and manage the connection to the database, we're going to use something called a data access object or a DAO pattern, and we're going to use that to manage the database connection. So as you can see, we're using quite sophisticated software architecture. All of this is going to be modular, and you'll see why this architecture is so important as we move into the next phase, because it's going to allow us to easily test our application using some cool tools such as Mockito and also something called Rest Assured. So this, like I said, is a real world application. This is exactly how you would create the backend for a mobile application. This is exactly how you would create a microservice. So we're going to have a lot of fun going through this tutorial, and you're going to learn loads. Okay, so the first thing we need to do is set a project up. So I'm going to be using Eclipse, but it's important to understand you can use any IDE you like, with the caveat being is you need to use Maven. So Maven is a project management and Java dependency tool. So it does a lot of things. It builds the project, it allows us to put in dependencies, it allows us to run lots of tasks. It's very, very powerful. We're already going to scratch the surface with it. Now, if you install Eclipse or IntelliJ, they have Maven pre-installed. If you want to use something like VS Code, you need to install Maven on your system. But it's important to understand Maven is not IntelliJ. Maven is not Eclipse. Maven is its own separate thing. So I'm going to open up Eclipse. Eclipse, there we go. Now, looking at the version, I'm using 2023 to 03, so make sure you are using the latest version of Eclipse. The first thing I'm going to do, I think, is I'm going to create a new workspace. So a workspace is where you create like projects. You can have many workspaces. So where am I going to create my workspace? So let's open up a folder. I'm going to go to desktop. I'm going to create one called Lab 5. And my workspace is going to be called Lab 5. I could have multiple projects in here. So that is going to be my new workspace. You can use your existing workspace, right? Okay, so let's do that. Okay, press Enter and press play there. Okay, so this is going to load up the workspace. So while this is loading, let's just consider, so this idea of Java, you have workspaces, it's quite a Java-y type thing, right? This idea of workspaces is a collection of like projects. They might have like configurations, they might be linked to similar domains, but it's just a collection of like projects. So if I click on these two windows up the top right, I have the Package Explorer. And you may have projects in here. What I'm going to do is I'm going to go File, New Maven Project up in the File menu at the top, or I can click Create a Maven Project just in the Package Explorer. Now, the first thing we're going to consider is this idea of an archetype. We do not want to use an archetype. An archetype is effectively a template for a Maven project. So it allows us to get started with a template. So there are things like Spring Boot that provides a complete web framework for us. There are archetypes that pull in testing frameworks. So you can think of it as a starting template. Very powerful, but we just want to create a simple project. I want to do everything from first principles in this lab so we understand exactly what we're doing. Okay, so let's click Next. Now, another thing that confuses some people is this idea of a group ID and an artifact ID. So a group ID is just an identifier for all of our projects, if you like. And normally what people do is they have the reverse of their domain name for their company. So we're just going to call this com.yet another to-do list. So yet.yatu, com.yatu. Artifact ID is the project folder, if you like. So you may want to call this to-do list, call it what you like, but it's the folder where the project's going to live. I'm just going to call it Yatu. So that can be quite confusing. So we have some other things down here. Versioning, this is a snapshot that we are going to create of our project, and we'll change that as we go through the different releases. And jar is how our project is going to be packaged. So remember, Java is a compiled language. Our source code gets compiled down to a jar file, and we're going to be using jar for packaging. There's other packaging kind of extensions you can use. I'm only aware of jar. That's the only one I use. So now we can click Finish. So let's do that. And you can see your project is created here on the right. What I like to do is click Go Into. I often see people and they have tons of projects down the left here. Try and focus as much as possible on the one you're working on. Now, you can see by default, we are using the Java runtime environment here. So this is the Java runtime environment. The Java runtime environment is a collection of files that allow our program to run. So we're currently using J2 Standard Edition 1.5, which is way too low. So what we're going to do is we're going to upgrade that now. Right-click Properties, and we're going to upgrade it. I'm going to upgrade it to 1.8. So really, any version a little bit higher than this, higher than 1.7 is fine. I'm going to upgrade to 1.8. You may only have 1.7 on your lab machines. It depends what version of Java you've got installed. Okay, cool. So now we've done that, we can start to explore what we've got here. So this is a typical Maven project structure. Now, the structure is dictated by the conventions used by Maven. And Maven favors convention over configuration. So there's a few folders, if you like, that we should be aware of. Now, I find sometimes this package explorer makes things a little bit confusing. So let's find this in the desktop and have a look at what we've got. So the best way to actually understand how a Maven project is structured is just to look at it in the desktop or look at it for a file explorer. So we've got a few things here that are Eclipse specific, so the class path, the project, the settings. You don't really need to worry about that. So the first thing to understand is a target. And a target is where the compiled version of our project goes. So when it's compiled down to a .jar, it gets placed in the target. And this is completely overwritten every time we do a new build. The next thing is you have your source, and the source is split into two parts, main and test. Main is where our main project is going to go, and tests, that we're going to look at later on, is where all of our testing will go. So tests are not going to be included in the main build, right? Because they're for development. Testing normally happens in development. So then we have within our main folder and also our test folder, this resources folder. And this is where things like static assets, databases, we're going to place our database in, go. So we have resources that we might have for testing, and we also have resources that we might have for development. And at the moment, we just have this blank Java folder, and that is where our main project is going to go. And within here, within Java, we'll have multiple other folders that might be nested within each other, and these represent packages. So in order to organize our code, we're going to split our work into different folders. This is specifically interesting when we're trying to set up different architectural patterns. So we might have a folder called model. We might have a folder called view. We might have a folder called controller. We're not actually going to set these the folders up manually, but these would be kind of different packages within our application. So a package really is just a folder. Cool, so let's get rid of those. So now we've got that set up, we are now good to go. You can see there's nothing currently in our main application, so we're going to change that in the next part of the tutorial. A few points. I've got a dark theme set up. I went to set this up, I went to help, Eclipse Marketplace, and I installed like this super cool dark theme. If I click installed here. So one of the problems with Eclipse is sometimes it's a bit laggy, it's a bit slow, it's quite a large framework. I personally would preference using something like VS Code, but Eclipse is perfectly fine. So I installed this darkest of darkest theme. Looks really nice, makes Eclipse look nice. So maybe install that, but you don't have to. I'm just saying if you want your application, your Eclipse to look like mine. Cool, okay, so now we can dive in and we can start making our application. So ensure you're using one of the latest versions of the Java SE. Okay, so the first thing we're going to do is install some dependencies. So dependencies are external packages that our program can use, And it basically means we don't have to make these things ourselves. So the first thing we're going to do is just understand how we actually find dependencies. There's a few different ways. So by far the most popular way, I think, is actually finding some sort of package that you like the look of. So this is Javelin, and it's a simple web framework for Java and Kotlin. Kotlin uses the JVM, but it's kind of a nicer version of Java. Probably shouldn't say nicer, that's subjective, right? So this is a simple, lightweight web framework. And what you'd normally do is view the documentation and read getting started. And then you can install that dependency by adding the dependency tag to the pom.xml file. We're going to talk a little bit about that in a second. You can see there's different package managers. So we are using Maven. Gradle is also very popular if you do mobile development. I've not actually heard of any of these other ones, but I'm sure they're very good. So there's always going to be different package managers used. Cool. Okay, so the next way is to actually use the repository itself. So this is mvnrepository.com, and you can search for packages in here. This isn't the most usable way of doing things, and quite often package repositories tend to be a little bit old-fashioned. And Java, a lot of the infrastructure seems a little bit dated, but you can use this to search, and that is what we're going to do. So what dependencies do we need? So firstly, we need a way to manage our database. So we've got a database. We're going to be using a SQLite database. So we're not going to write the drivers ourselves to interact with the SQLite database. We're going to pull in a package, and we need something to manage the API. And that is going to be Javelin. There's going to be a few other dependencies that we install along the way, because dependencies often themselves have dependencies, and Javelin is going to ask us to install an extra dependency later on, but we'll address those when we need to. Okay, so let's consider how we might install a dependency. So pom.xml is effectively, I'm going to zoom in a bit so you can actually see what this is effectively a description of your project, and it's going to have things within it. It's an XML file. It's going to have things within it, such as the project name. So we called it com.yatl. Sorry, that's the group ID. The artifact, which we set earlier, which is just yatl, and the snapshot. So all of that we set earlier, and this is kind of the most simple pom.xml you can have. So pom.xml, I think it stands for something object model. I'm not sure what the P stands for off the top of my head, but you can Google it. So it's XML, and it can have various different things in it. It's very powerful. We can set up full build pipelines for our application within here. But for now, all we want to do is add some dependencies. And we're going to set up a tag called dependencies. Now, XML is interesting, right? It's kind of like HTML, but it's very, very strict. So if I didn't close this tag, you can see I get an error there. So within this tag, we can add one or more, or as many as we like, dependencies. How do we find those dependencies? Well, we go to the vendor site, such as javelin.org, or we can search them. So let's just see if we can find Javelin to begin with. So Javelin, so it's Javelin spelt with an A. And you can see Javelin comes up. And also this idea of a group ID, io.javelin. Remember me saying the group ID is normally the reverse of the domain name. So you can see javelin.io, io.javelin is the group ID. So let's click on this. You can see there's multiple versions. So this is a really cool thing about package management. If you need an earlier version, you can just click on here. And then when you're ready, you can upgrade. But because we're adding the dependency to the pom.xml, we're always going to be working with 6.1.2. And any developer that uses our project will get that as a dependency. If I was to say to you, go and download the .jar for Javelin, you could do that. You could use it, but you might be using a different version. So let's grab this and chuck it in the dependencies. I'm going to just format this. Format Command-Shift-F, so I'm just going to format that. So this is a comment like HTML, that's a comment, so that's not going to be included. Let's add our SQLite dependency, so we can go SQLite and search for that. Click search. And yep, org.xserial is a company, or the people that create the SQLite plugin. And we want this one here. We want SQLite JDBC, I believe. I will just double check that on my notes. Yes, we do. We want SQLite JDBC. And I just want to check I'm using the right version. Yep, 3.4.51. And again, normally you're going to know what you need, right, if you search for here. So it's not an exploration process going through the Maven repository. You'll find a tutorial, you'll be watching something like this, and they're saying install SQLite, and you'll kind of know what to use. And let's just do that. And again, format there. Okay, cool. Okay, so they're the two dependencies, and you can already see my Maven dependencies have been pulled in here. So Eclipse is managing that process very well for me, and you can see I have a load of .jars pulled in here. Some of these dependencies have other dependencies, but now I have access to these awesome libraries that we're going to be using. Sometimes you'll notice your dependencies don't get pulled in. Then all you have to do is you have to go run as, and you can do Maven install, and that will make sure everything is installed for you. So Maven install is one of the processes that is available to me because I'm using Maven. Okay, cool. So we are now ready to get started with the core part of our application, actually setting the database up and setting up the MVC architecture. The first thing we're going to want to do is create an entry point for our application. So let's use this as an opportunity to start to figure out how we're going to organize our code. So source main Java is where our application is going to go. Within there, we are going to create a package that's kind of the root package for our entire application. So you go new, package, and it's going to default to YATL, but we're going to call it com.yatl. That's kind of Java convention. So this is actually going to create two folders. Remember, packages map to folders. It's going to create one called com, and within it, it's going to create another folder called YATL. And now we have our package there. So kind of Eclipse simplifies the view, but if we were to look in a package explorer, sorry, a file explorer, not a package explorer, you can see we have com YATL. So within here, let's create our main class. Now this is going to be the entry point to our application. Now you can call this what you want. Some people call it app, some people call it main. You can call it banana, it doesn't actually matter. What does matter is that there is a public static void main method within it. And that is the entry point, no matter how large your Java application is, for any application. Okay, so we're going to use some shorthand here. The thing about Java is it is verbose, but once you start to get to grips with your editor that you're using or your IDE, things become much quicker, and there's lots of shortcuts you can use. So I can type main in Eclipse, press Control Space, enter, and it's going to create a public static void main method for me. I can type sys out, Control Space again, and it's going to write system.out.println. So again, it's about trying to use the tools you have on hand. We don't teach tools, right? But it's up to you to try and explore whatever IDE you like to use. I'm not saying one's better than the other. Okay, so let's just run this and check that it runs. So if I press play, just says I have to save it, so it's saving. I have hello world down there. So there's two ways I can do this. Because this is the static void main, it's always going to run, right? So I can just press the play button, or some people like to do this, run as Java application, and that effectively does the same thing. Okay, so the first order of business is we need to create a to-do list database. Now we're using SQLite. And SQLite gives us a couple of options. It allows us to store a database as a file locally to our project, and that's the route we're taking for this application. It also allows us to store a database entirely in memory, and that's really handy for things like testing, where the database doesn't need to extend its life cycle beyond the execution of our tests. So where should we keep this? Where should we create this? So there's a few different ways to create a SQLite database. So you can install a GUI client, and I've linked to one in the notes. You can install a terminal tool, SQLite terminal tool, and that allows you to create SQLite databases, or you can use a package in a programming language like Java, which is what we're going to be doing. We're going to be using a SQLite package to create a to-dos table and add some to-dos to it. And that's absolutely fine for our needs. So we're going to create a file or a class called Cedar, and that's going to create the SQLite database for us. It's going to add some to-dos. It's not really part of our main application. Quite often you have bootstrapping tools within an application that allow you to do things like populate a database. So where do we want to create this class? Well, you could just chuck everything into one package, right? But things will quickly become unwieldy. So what we want to do is we want to create a package called util, and this is where all of our utility classes are going to go for our entire application. So remember, a package is just a folder, right? So a folder called utils. So let's create this package. You've already got com.yatil, that's our main package there. And if I just say .util, remember this convention, each dot is effectively another folder identified with the string after the dot. So this is going to create a util folder. And there we go. So you'd expect, wouldn't you, that this should be kind of nested within here, but it's not. If you look at the folder structure, I'm going to go to my desktop and just look at the folder structure here. You can see that util is indeed nested within here, and we have our main class, and then we'll have util here, then we'll have our other packages that are going to hold parts of our MVC application. So within here, let's create a new class called Cedar. And Cedar is going to seed our database. Okay, so before we connect to the database, I just want to go over how a Java database connection works. So I've got this geeksforgeeks.org introduction to JDBC article, and it's got this really nice diagram here. So JDBC, Java Database Connection, is actually a really interesting idea because it allows us to connect to literally any data source. And what we use is something called the JDBC driver manager, which is an object, and based on the connection URL we pass into the constructor of the JDBC driver manager, it's going to hand us back a connection for our specific database. So what it's going to do is it's going to look for the specific driver. So in our case, it's going to look for a SQLite driver, and it's going to hand us back a connection. And that connection object always gives us a set of standardized methods. So it's a standard interface. So it's this lovely idea of abstraction, and this idea that we can connect to literally any data source, and the JDBC manager will sort it out for us and grab the drivers. So in our case, we're using a SQLite database, and if you remember earlier, we installed the SQLite JDBC driver. And if you don't believe me, you can check in the Maven dependencies here, and you can see we have the SQLite JDBC driver, and that's a .jar file. In case you're wondering, a .jar file is a compiled version of a Java application. And if you actually look in our target folder there, you can see Maven has created a .jar for us. So this is actually our application in its compiled form. Okay, so SQLite is going to create a database for us. There are a couple of representations you can have when it comes to SQLite. The first and most popular is just a SQLite file database. So the database is going to consist of a single file. This differs to something like a MySQL database where you need to run a server. So a SQLite database you can have, if you want, a single file. It lives with the application. And it's ideal for things like local storage. So if you're making a mobile application, you can store local information right alongside your application. So it's really, really handy. Let's just come into Cedar here. So the first thing we're going to do is set up a constructor, and we're just going to put all of our code into the constructor. Now this probably isn't best practice, but it doesn't really matter because this is just a utility class. It's not really part of our main application, so we can be a bit liberal when it comes to the code that we place in there. Okay, so a constructor is just public Cedar, same name as a class. So just a little recap, you should know by now that when you instantiate an object, when you say new Cedar, what you're effectively doing is calling this constructor. So you can pass in values here, or you can just leave it blank and you would invoke the object or instantiate the object if you're talking in OO speak, like that. So new Cedar. Okay, so the first thing we need to do is set up a database path. This is where our database is going to live. This is just going to be a string. Database path equals. And recall me saying things like file databases, static assets go in the resource folder of your main folder. So source main resources. I can right click here, click copy, and then paste in that address or that file path, that address. It's not an address. The next thing we need to do is say / and then name the database. We can be creative and call it database.db. And then just semicolon to end the line. The next thing I need to do is construct the connection string. And if you recall me saying earlier, the connection string is what the drive manager uses to determine what driver it's going to load in. So in our case, SQLite. And the connection string is always the same. It consists of multiple parts separated by a semicolon, but it's for now going to be a string URL. I'm just calling it URL really, just to differentiate it from path, but you can call it what you like, right? It doesn't matter. The first thing we're going to say is JDBC, so we're using the Java Database Connection Protocol, and for us we're using SQLite, so I separate that by a colon, SQLite. I then have another colon, and after that we have the path which we constructed above. Now you could just type the path in here, right? But I quite like having it separate. So plus database path, and plus is the way to join strings together in Java. Okay, so we're now ready to ask the driver manager to give us a connection to our database. And it's literally going to hand back a connection, which we are going to call con. And we say driver manager, get me a connection, get a connection. And you can see it's auto-completed that for me. Okay, so a couple of things have happened here. You can see java.sql.driverManager has been imported. Connection hasn't. So let's say command. So let's do command or control-1 and then click import. And what I like to do is I like to use the IDE and specifically the errors that the IDE is telling me to guide me in my programming. And I think that's a really, really good tip. So you can see now we've got another error and it's saying unhandled SQL exception. And that is because getConnection throws a SQL exception. And at the moment, we're not handling that. So there's two things we could do. The first thing we can say is throws SQL exception. And we can put that in the method signature. And this means when we use Cedar, in another method, we'll have to handle the exception there. So we're effectively delegating away the SQL exception. So that's one strategy. But for now, what we're going to do is we're going to get rid of this. For now, we are going to actually just handle this exception within this method here. So I'm going to click surround with try catch. How do I get this up? So I can hover over here. I can hover over Drive Manager and it does it for me, or I can press Control-1 or Command-1 if you're on a Mac, and I'm going to surround this with try catch. You can see we're now catching a SQL connection there. Okay, so now we can actually start writing some SQL. First thing we're going to do is just make sure we actually have a connection, and we're saying if connection not equal to null. And what we're going to do is we're going to do sysout and just say connected to database, so we know we're connected. Database. And now what we can do is we can ask the connection to hand us a statement object, and we can use the statement object to execute queries. And these are just going to be standard SQL queries. So statement is going to equal con.create statement. Con.create statement. And again, we come back to here, command 1 or control 1, and we import statement. Okay. So this is going to be quite familiar to you if you've done databases before, which you guys have. We could literally just say stmt statement dot execute, and we could just pass into the statement a string. And this is just going to be a standard SQL query. So we could say something like this: drop table if exists. Let me just check I've spelled that right. EXISTS, exists, to-dos. Drop table if exists, to-dos. And we're going to want to do this because if we have a to-dos table, we're going to drop it and then we're going to recreate it. I'm not going to type in all the creational code. I'm going to grab that from the solutions in a minute. But let's just check first that this actually works. So I'm going to come back to main here. And you can see I've actually already imported Cedar up the top there. So import com.yatl.util.cedar, and then we can say new Cedar. And that is going to instantiate a new Cedar object. And by the very process of doing that, it's going to run the constructor here, and it should go through. And it's worth noting that SQLite will create the database for us if it doesn't exist, and then on each future run it will use the existing database. Okay, so it doesn't just create a new database every time. Okay, so let's check out if this actually works. And it does say indeed connected to database. We haven't actually done anything yet, but we have connected to the database. It looks like we've established a connection. And what we're going to do now is we're actually going to create some data in the database. We haven't actually created any data yet. And what I'm going to do is I'm going to go to the solutions. So this is a public repository. And the address is gitlab.surrey.ac.uk/com_1028_labs/lab-5. And this is a Git repository, and it has multiple branches. And I create a branch for each exercise solution. So we're going to click on exercise 1 solution, source main, and then we're going to click on util, and we're going to click on Cedar. And all I'm going to do is grab all of this stuff and paste it in. And you can see we're effectively doing the same thing, but we've got some create statements here and then some insert statements to insert some data into the database. It just saves me from typing. So let's do this. And let's save that. I just want to go over a few points here. So the first thing to note that we're doing additionally is we are creating a to-dos table. So our database is only going to have one table just to keep things simple. It's got an ID, which is auto increment. It's got a title, and it has this attribute completed, which is Boolean, and it's going to default to 0, default to false. So because ID is auto increment, because Boolean default or completed defaults to false, we can get away with just inserting title, which is not null, right? So we have to have a title. So insert a few things, and notice down here, ACE software engineering, we've done that, right? You've already ACE software engineering. So I've inserted the value 1 there, just to have like one separate, like done to do, and that's useful later on. We are then down here actually just grabbing some data, and we're only doing this to test that everything is there. So we select all from to-dos, select star from to-dos. And this is an interesting idea, right? So this, when we execute a query, we actually get a result set back. Now you might think that that result set should contain all the results. It doesn't. It is a pointer to the results. And we have to iterate using an iterator. So we're saying rs.next over the results in order to get access to them. So this is a standard like iterator pattern. And we iterate across and we're basically updating the pointer. And then we can do this, rs.getInt ID to get the ID out, rs.getString title to get the title out, rs.getBoolean. So notice we can get different data types completed. And these map to these fields up here, right, that we just set up. So remember, result set isn't really a set of the results, it's just a pointer. And we can iterate and we can move the pointer by calling rs.next. So that's what's going on there. Okay, so if all works properly, we should print out the results of our database. So let's run this again. And you can see, connected to database, learn Java false, vote for Joe false. That means you haven't done that yet. You've got to vote for me. I don't know what in yet, but maybe there's an opportunity to vote for me. Buy a car, you haven't bought a car yet, so that's false. And you have aced software engineering. And you can see now we have a database set up in our resource folder. Now, if you download a database client, which I have one, you can actually open it up and have a look. You can also access this through command line if you have a command line database client. So just search SQLite database client. This one's Table Plus. And if I click on to-dos, let's see if I can zoom in a bit, you can see I've got 4 to-dos in there. And you can see that the database is just stored. It is just a file alongside my application. So super handy. Cool. So we've done a lot. We set the database up and we're now ready to dive in and actually create kind of the main MVC part of our application. Okay, so first thing that we're going to want to do, I'm just going to take my headphones off, in this MVC application programming journey is think of a better way to manage our database connection. So you can see in Cedar, we are setting up a new database connection, and then we are connecting to the database and running queries. Now you may think, I could just do this every single time I wanted to use a database. And that would work up to a point. But there are numerous issues with this technique. Firstly, you could just spell this path incorrectly and you'll set up another database. Secondly, we could accidentally set up multiple database connections. Now this is fine for our application, right? But if you have thousands or hundreds of thousands of users, setting up more than one database connection would add a strain to resources. So we need a way to ensure we only have a single database connection in our entire application. So a single source of truth. And there is a very special design pattern that we can use. So if you attended my lecture, you'll be familiar with the idea of design patterns. They are there for us to solve common programming problems. And in object-oriented programming, one issue we have is it's quite hard to have a single instance of something. Because if I define one class, there can always be multiple instances of that class. So somebody could just keep going, new database, and they would have multiple instances. So we're going to use something called the single pattern to solve this common occurring problem. And this is a really, really good example of it. So the Singleton pattern does not allow external classes to instantiate a new object. And you can see the constructor there with this little negative sign is private. And instead it has this static method. So a static method belongs to the class. A static method belongs to the class. And the static method manages a single instance of database. So it will return a single instance of this object, and it maintains a single instance. So you have the class, it creates one object, and it ensures no more than one object is instantiated. And then we can just grab the connection from our database, and using the connection, we can create a statement and just run this code. So let's go ahead and see if we can set up this Singleton method. So I'm going to create a new class. I'm going to leave it in util. Sometimes people like to have like a database package. I'm just going to leave it in util. Doesn't matter. I'm going to call that database. I'm going to call it database. And we're going to set up our Singleton instance. And I think, it's one of the most simple design patterns you can actually look at. So hopefully you're going to understand it. So the first thing we're going to do is set up a property or an attribute to hold our instance. And notice this is of type this class here, database. And this is going to hold an instance of our database connection, and it's going to pass it back to any class that wants to use our database. And notice how it's static. That's really important. It's static. It belongs to the class. We're then going to have a connection. The connection is not going to be static. And this is just going to be our SQL connection. And let's import that. And we can use that connection to grab a statement, and we can use the statement to execute queries. Now, this is a fundamental part of the Singleton design pattern, and that is the constructor is private. So this means I can't say new database. It's not going to allow me to do that. Instead, I have to use a static method on the database class in order to instantiate a new database. So this is going to take in the path to our database, gives us a little bit of flexibility. You don't want to hard code a path. You don't want to tightly couple this class to a specific database. You want to use it with any database. Then we're going to instantiate the connection. So we're going to say this dot connection equals, and you've seen this before, when we were using our seeder, we used the driver manager, right, to get a connection, and we just passed in the path there. Okay, so we are going to surround with try-catch blocks. I think that's fine for now. We're now going to implement some Singleton magic. So we are going to have a public static. They're going to pass back the instance. So we're going to have a public static method that passes back an instance of this class, or it will create one for us, and it's going to be called getInstance. And again, this is going to take in the path. Okay, so it's going to give us an error at the moment because we're not returning anything. This method does not return type database. So a static method means we can actually call this method without creating an object. So you'll kind of understand that normally you'd have to say new database, then you'll say database.getInstance. But in this case, we can just say database.getInstance because it's a static method. We can call it like this, and then we can pass in some path here. Because it's static, we don't have to say new database, and it always belongs to the class. So static methods, a little bit confusing, but if you play around with them a bit, you kind of start to understand why you need them and why they are useful. Okay, so the first thing we want to check is, do we already have an instance? In fact, we're going to do this the opposite way around. We're going to say, if we don't have an instance, we're going to create a new instance of database and return it. So we can do this, if instance. So if instance, which is this property here, this attribute here, if instance is equal to null, that means it's not instantiated yet, so we don't have an instance. We are going to say set instance equal to new database. Okay, so to new database, I'm going to pass in the path there. Okay, cool. So you can see this is a private constructor, right? So we can call it within the class, we just can't call it externally. And the external users of this class are going to call this static method here. And then this static method checks to see if there's an instance. If there isn't, in this case, it's going to create a new one. If there is, though, we're just going to return the instance. And this is kind of like a little bit of coding trickery. I really like this approach. So what I'm basically doing here is I'm saying if instance equals null, let's set it up. If instance is not equal to null, we already have an instance, we just return it. So either way, I'm either getting a new instance or I'm returning the existing instance. Some people may be tempted to do like an else block there. I very rarely use else's when I'm programming. Try and avoid it. Okay, so the final thing we need to do is set a getter method up for our connection. Let's do that now. So public connection, get connection, and you know this, right? You're just going to return connection. Return connection. Okay, cool. Okay, so that's pretty much all we need to do to set up our Singleton method. Let's go ahead and see now if we can use it. So what we're going to do is we are going to grab some code from the seeder. That's what we're going to do. So let's just grab this bit of code here from the seeder and let's come back to main. So we don't need the seeder anymore. I'm just going to delete it. And let's see if we can set up a connection. So I'm just going to comment out this code for now. So the first thing we need to do is get a instance of our database. Get our instance of our database. So we can say database equals, and let's import our database at the top. Import com.util.database. So database, if I actually spell database right. So okay, so what we're going to do is set up a new instance of database. What's going on here? I don't know what's. Oh, did you see that? It's voice oh, so it's actually it started doing. Oh, okay. Okay, so for some reason there, I managed to activate voice dictation. So now back to the actual task in hand. Okay, so we're not going to use the drive manager to set the connection up. We're actually going to use our database class. So let's go ahead and just see if we can do that. So database equals, you may be tempted to do new database, but remember we can't do that. .get instance, database.get instance, and that's going to take in a URL, right? That's going to take in a URL or a full path to the database. So I'm just going to grab these two lines here. And then we're just going to pass in the database path. Sorry, the URL. We're going to pass in the URL. Okay, cool. So now we should be able to get a connection, but we're not getting the connection from the drive manager anymore. We're getting it from our database class. So let's do that. So connection con equals database.get connection. Sorry, my bad. It's database.get connection, right? Okay, so now we have the connection. We can grab a statement and we can just execute those statements, just execute the SQL on the database. So if I was to do this again, right? If I was to say database 2, these two instances would be equal because I only ever have one instance of database. So let's just see if all of this works. Let's come back to Cedar and let's see what we can do. So what I'm going to do is let's just grab this stuff here. In fact, all I'm going to do is grab the last bit where I'm just grabbing stuff out. I'm grabbing a result set from the database. I don't need to do all these inserts, so let's just see what we can do here. Okay, so the first thing I need to do is get a statement. Statement is going to equal stmt. No, it's not. It's going to equal con dot get. Is it get statement? Con dot. Come back to Cedar so I remember what this is. Create statement. So statement stmt equals con dot create statement. Okay. So let's import statement. Let's spell this correctly. So con dot create statement. So it's going to give us an error because we don't have try catch blocks. So let's click surround with try catch box. So we're going to do that now. So surround with try catch. And we're also going to move this whole block into this whole block. Can I do right click cut? Oh, there we go. Right click cut. Okay, there we go. So we're going to move this whole block up into here. And that should be fine now. So let's test that this can select all of our to-dos. Now remember, we earlier ran the Cedar, so we should have some to-dos in there. And remember how we use our result set. Result set is just a pointer, and it uses the iterator pattern to kind of move the pointer along. So every time I call rs.next, rs is pointing to the next to do, which is why I can then say rs.getInt, and it will get the ID of the existing to do. So we can get rid of Cedar now. We don't need it. And let's just run this and check we get the output we're looking for, which we do. So awesome. So now we have a wonderful Singleton database connection. We will now jump into the rest of our MVC application. Okay, so before we dive in and create our model, let's just quickly review the MVC pattern. So this is what the MVC pattern looks like. Let me see if I can actually get a pen up here. So we have our model, and this is the first part of kind of the entire pattern. And you could think of the model as just a placeholder for data. So generally what you'd have is you'd have a database. The database would have multiple tables, and each table would have its own model. So the model is there really to hold a single record in a table. So for to do, we are going to construct a model that will just hold a single to do item. And we only have one table. In a larger application, you may have multiple tables. You might have another one called categories, users, whatever, right? And you would have a separate model for each. And these are going to live in a model package. So let's go ahead and create our models. So the first thing we're going to do is we are going to create a new package. What do you think the package is going to be called? So we're going to call it com.yatl.model. com.yatl.model. And this is going to contain all of our models. So software architecture really is just about organizing code. So that's really what we're doing here. And let's create a new model. And I'm going to call the model to do. So model is just a class, and models are actually the most simple part of the MVC pattern, because all we're actually doing is creating a class to represent a table record. So let's call this to do. And generally speaking, I call models singular, a singular version of the table name. So if I have to-dos, table called to-dos, the model will be to do. And that makes sense because a model holds a singular record. Okay, so the first thing we need to do is create attributes for each of our items. So for each field that we have in our to-dos list or our to-dos table. So let's just have a quick look at let's just have a quick look at Cedar. So you can see in our to-dos table we have the following fields, the following columns. Let's call them columns, shall we? So we have ID, which is an integer. We have title, which is text. So that's just going to be string. And then we have this Boolean value. So let's go ahead and add these as attributes on our model. And attributes on a class are normally going to be private, right? And this is just a standard plain Java class, right? There's nothing crazy going on here. The interesting part to this is objects are actually very good at representing things in a database. So object-oriented programming makes a lot of sense for things like object schemas or to represent things in a database. Other places it's quite tricky to think what do these classes look like, but when it comes to models it's really straightforward. So we have private int ID, we have private string title, and then we have private Boolean done. So again, just to reiterate, these are just standard attributes on a class, and these map to the columns in our to-do table. Okay, so the first thing that we're going to want to do is we are going to want to set up a constructor that's going to initiate all of these values. Let's see if we can auto-generate that constructor. So if I right-click and I go to source down here, see if I can generate the constructor. Generate constructor using fields. So I'm going to generate constructor using fields, and we just click generate, and you can see does it for me. So it takes in an ID, a title, and it's also going to take in done, and it's just going to instantiate that class. We don't need to call super, so just delete that. I don't know why it does that, because we're not extending anything. I don't need to do that. Okay, so next thing we want to do is add getters and setters for each of these fields. So let's go ahead and do that. But also we're going to do a little bit of magic as well. So if we just do right click, we go down to source, and we can generate down here getters and setters. So generate getters and setters for all of these, and we just click generate, and there we go. So we now have getters and setters. And the final thing we want to do is set up a toString method. This is quite common, and it just allows us to easily print out a record. Going to look like this: public string toString, and it's going to return. And this is just for debugging, really. To do. So it's going to return this record to do, And let's just add some stuff. So we're going to say this .id plus, we might want to put a space in there, plus this .title. And it's just literally going to return the values, right? Plus space, plus this dot. Done. So there we go, people. That is our model. So let's just see now if we can actually use this model to hold a to-do. So let's test it out in our main method. So let's have a look at what we've got here. So at the moment, we're pulling out all of the to-dos from the table and we're printing them straight to the terminal. Let's see if we can store these in a list of to-dos. So I'm going to set up a static list up the top here. The reason why I'm using static, because main is a static method, but you know, don't worry, just understand this has to be here for now. We don't normally need to use static. Static list to-dos is going to equal a new if I can actually type today. So we're going to have a static list, and it's going to be a list of our to-do models, right? So it's going to be a list of our to-do models. We're going to call it to-dos, and it's going to be a new array list. So let's save that, and let's import our missing. Let's import our missing things. So static list, so we're going to import. Sometimes it allows me to auto import, right? But it doesn't sometimes. So there we go. That's why I'm having to type this in. So import java.util.star would do it, but we want to be a bit more selective. So let's say .list, and then import java.util. I think it's array list. Is it util.array list? There we go. Okay, so now that's fine, and we also have to import our to-do model. Let's just see if it will auto do that for me. No, it doesn't. It doesn't want to do it for me automatically. Okay, so let's just do that then. So import, and this is coming from our main application, right? com.yatil.model. .to-do. .to-do. Okay, cool. So we've now got our list. Obviously, we are not actually doing anything yet with our list. So let's see if, instead of printing to the screen here, we can actually add to our list. So what we want to do is we want to say to-dos.add. And that's how you add to an array list, right? To-dos.add. And then in here, we're going to set up a new to-do item, right? And this is going to take in a few things. So the first thing it's going to take in is an ID, so we can just grab this from here. So remember, this is a pointer, and we're saying to the pointer, get me the ID where you're currently pointing, rs.id. The next thing we're going to take in is the title, and then finally the boolean of whether it's completed. So the title is a string, so pass that in there. Pass that in there, and then finally we're going to pass in the completed, the status if you like, and there we go. So now we can get rid of this, and we should now be setting up a list of to-dos. So just to, what's it saying here? Is it saying I've got no? Okay, I've got to put a semicolon at the end of the line. And what have I done wrong here? What's it saying? So we'll have a look and just fix this. Syntax error. Okay, so I'm missing also a bracket. There we go. Okay, so let's just see now, after we set up our loop, so to just recap what we're doing, we're setting up a pointer based off this query here, which grabs all the to-dos from the database. We iterate across, and we create a new to-do for each item in our database, and we add that to our to-dos list. So we should have a to-dos list here, which is a list of to-dos models, right? So a list of models. So let's set up a second loop and see if we can use to-do.toString. Did I call it toString? Let's double check. I think I did. Down here. Yep, to-dos.toString. Let's see if we can use that to print out our to-dos, just to test that everything's working. So we're going to use a for loop, and this is really handy. This is actually like a really nice part of Java. So we could say to do. So we can then pass in after this semicolon to-dos, right? To-dos. So this is going to iterate over the entire list and hand us a to-do each time. So to-do will be the latest to-do model, and we could do sys out, and then we can do to-do.toString, and we should, if everything's gone right, see the same output as we saw before. So let's just run this, and there we go. There we go. And now you can see we've got this kind of pre-appended to-do bit because that's what we added to our toString method. So cool. So now we set up the model. The next part is to add something called a data access object, and this will contain all of the interaction logic with the database. All right then. So at this stage, we could go ahead and make our controller, but I want to do a bit of refactoring first. So refactoring is this idea of effectively restructuring or changing our code to make it better. Now, I can see an issue that we currently have. So you can see here, although we have set up a Singleton class for our database connection, we are still effectively communicating directly with the database. And then every time we communicate with the database, we need to iterate over the results and set up our models in this list. So we're going to have quite a lot of repetitive code, and also we're going to be potentially communicating in an inconsistent way with the database. So a common pattern to manage this problem is known as a DAO, as a data access object. And the data access object mediates all of the communication with the database for the entire application. So you know, if you need to change some logic with the database, you just have to update the DAO. You don't have to go and find every execute query command in the entire application and change it. So let's go ahead and look at how we can set up our DAO. So what we're going to do is create a new package. And the package is going to be com.yatl.dao for data access object. And typically what you'd have is you'd have a DAO for each table in your database, and the DAO contains all of the logic for communicating with that table. So for instance, we're going to have get all to-dos there. You might have another method, get to do by ID. But the key thing to understand here is all the communication with the table happens in a specific DAO. This is the pattern we're following. So let's set up to-do.dao.java. To-do.dao.java. Okay, so to-do.dao is going to use a database connection to generate a statement, and then it's going to execute that statement and construct, for instance, a list of to-dos. That's really its job. So we're going to need a connection. So I'm going to use private final, and this means the connection cannot be redefined. Private final. So it's like a constant. Normally good practice to do this. So let's set up connection here. How are we going to get the connection? Well, we're going to use our database class, right? We're going to use our database class to get the connection. So let's import connection from Java SQL connection, and it's going to give us an error because we haven't initialized connection yet. So that's because we've got private final. So it has to be initialized with a value in the constructor, and it can only be assigned a value once. Okay, so let's set up a constructor. Public to do DAO. And within here, we are going to set up our connection. So how do we do this? So let's come back to here. So you can see we already have a database connection in our app. So we can say database.getInstance, but you can see here, this isn't the most convenient thing because we have to keep passing in the URL every time you want to get an instance. And really you only need to do that the first time you create the database. So let's refactor our database class now so we can have the option of instantiating it or getting an instance without having to pass in the path. Now there's something called overriding in Java or in OO in general. And it's this idea that I can have the same method but with a different signature. So for instance, the same method name, you see these method names are the same, get instance. But in this case, I am not passing in a path, So the first time I get the instance, I do want to pass in a path because I want to set the database up. But for future occurrences, it's fine. We can use this. And this is called overriding. So if I call get instance without passing in a path, this method will be invoked. And if I pass in a path, this method will be invoked. So the first thing we do want to check though, is we need to ensure we do have an instance, right? Because if we don't, this method needs to be called up here. So let's throw a legal argument exception. So we're going to throw new illegal state exception. And we're going to say you must first call, actually, let's just put in something really simple. Currently, get instance has not been called. Okay, so we're going to throw a legal state exception. So let's just import. What's it saying here? Have I spelled this wrong? Change to exception, create class, illegal state exception, extends exception. No, I don't want to do that. I've probably spelled it wrong. ILLEGALSTATE, exception. Okay. Should be okay. Let's just see what happens. Okay, so otherwise I am just going to return an instance. Return an instance. Okay, so I still got this error here. Gosh, what have I done? So, okay, I spelled illegal wrong. Have I spelled illegal? There we go. I spelled illegal wrong. Okay, so now we're okay. And this is really, really cool because now what we can do is we can, in our main method here, set our database connection up once. So when we get the instance here, we can pass the URL in, and then in any future uses, such as in to-do DAO, we can just do this. So we can say database equals database.get instance there. And then we can set our connection up. But notice we don't have to pass a path in. So that's really, really handy. Con equals database.get connection. So we're setting up our connection there. And for now, we're just going to add one method to do DAO. and that's going to be get all. So that's going to get all the to-dos. But as we go through and create the remainder of the application, we'll start adding more methods like get, by ID, that sort of thing. Okay. So public, and this is going to return a list of to-dos, right? A list of to-dos. It's going to be called get all. And it's going to throw a SQL exception. It's going to throw a SQL exception. Let's just import these missing items. Import. And I think we have to import SQL exception. There we go. So let's use the logic that we've got already in our main class to construct this, because we're already kind of doing this in main. So really, we just want to do this, right? So let's copy this from here. And let's just drop this. Let's make sure it's saved. Oh, have I got an error there? Sorry, I haven't got a semicolon at the end of the line. There we go. Okay, so let's come to here and let's paste in this. So that's going to be a statement. Import statement. And we need to establish our to-dos list up the top here. List to-dos. And in fact, I'm feeling lazy. I'm just going to copy this from here. And it's not static anymore. We don't need this to be static anymore. Can I copy and paste? Let's try again. Copy, copy, and paste. Okay, list to-dos equals new array list. We're going to iterate over the array list, and then we're going to have to return the to-dos. Return to-dos. And we should now get rid of all our errors, and we do. And that is our DAO. So let's see now if we can go to main and use our to-do DAO. So we can get rid of all of this stuff here now. In fact, what will we do? The best way to do it. Let's get rid of this stuff up here. And let's say to-do DAO. To-do DAO equals new to-do DAO. And let's import that. Is the import going to work automatically? No, it's not. So, okay, so let's import the to-do DAO. Import com.yatl.dao dot to-do DAO. Okay, so to-do DAO equal, and we'll sort this out in a minute, don't worry. To-do DAO equals new to-do DAO, and then we can grab our to-dos. So we've already got a list set up, and we're going to say list, and we're going to do it like this. We're going to say to-dos equals to-do DAO. I'm just going to put an O on the end there. Doesn't matter. I can call that variable what I like, but it just makes sense to kind of keep consistency. To-do DAO dot get all. I'm going to save that. So what's it saying here? Oh, did we call it? What did we call it? I just think we didn't save it. So let's come back now and yep, that's fine now. Okay, cool. So now we should be using our DAO to get a list of to-dos. So notice there's no SQL in here. Another cool thing we're doing is we are setting our database connection up once here and getting the first instance, passing in the URL for each future use of it, because we're only having one instance in the entire app. That's the idea of the Singleton method. For every future instance, we don't have to pass a URL in because we're using overriding. I'm just getting rid of some of these unused classes, and we can even do this. we don't actually need to save the database anymore. We just need to set it up. So notice how our code's becoming much cleaner. Now let's run this and see if it actually works. We can get rid of some of this stuff up here as well. These aren't used, which is why we have some warnings. So let's get rid of those. Tidying everything up. And let's check this works. And there we go. So this still works, and we are now using our DAO, and we have this kind of single layer that handles all of our database logic. Okay, so we're now ready to finish off our application. So let's stop the server from running. So we'll just press stop here. So stop in the console there, and now the application should have stopped running. And let's consider what we need to do. So at the moment we're serving up these routes, but we're not returning JSON, we're just returning a string. So the first thing we're going to do is implement this getToDo's method fully. Before I can do that, I need to add a controller. So let's do that. And you've probably guessed we need to create a new controller package. So new package com.yatl.controller. And I'm going to create within that a to-do controller. So really you'll have a controller for each object, if you like, within your application. So we're going to create a to-do controller. And the controller is going to process the HTTP request. So at the moment in app config, we are immediately processing the request using this Lambda function, but the controller is actually going to handle the request. So it's going to take in a Javelin context, it's going to handle the request, and then it's going to return something. In this case, it's going to be JSON, right? So first thing we need to do is we're going to need access to the to-do DAO, because we need that to grab to-dos out. We're not going to create a new to-do DAO in here. We're going to pass it in. We're going to pass the DAO in. The reason being, as soon as you start creating new things within a class, you're tightly coupling that class to the new thing you've created, and it can make testing a little trickier. So that's why we do this. So let's set up our constructor. So public to-do controller, and it's going to take in a to-do DAO. To-do DAO. Let's just sort out some of these issues we've got. So we're going to import the to-do DAO. And this is just standard JavaScript at the moment. So notice, because I've named the parameter the same as the field on the class, I use this just to say I am referencing the field, not the parameter. You've probably worked that out. Okay, cool. So now we set up our DAO. We have access to all of the methods within the DAO. At the moment, we've only implemented one method, but as we go through this, we're going to implement some more methods. I'll just free up some space down here. Okay, so the first thing we might want to do is get all to-dos. Public void. So notice we're not actually returning anything. You may think you should return a list of to-dos here. No, we're not. We're just processing an HTTP response and sending back some JSON to the client, which is just the browser in this case. We're going to call this get all to-dos, and we're going to take in a context, and this is going to be a Javelin context, CTX, and this effectively is the HTTP request. And if you're familiar with Express, remember we looked at that in web development, or the web development part of web databases and web development. You'll understand it's very similar to that. So we're going to import the context from Javelin, and let's see if we can process the response. So the first thing I want to do is I want to set up a list of to-dos, and I want to grab all of the to-dos from the to-dos DAO, right? DAO dot, just spell all this stuff right, to-do's DAO dot get all. And let's just pull in these dependencies, import list and import our to-do. So this is saying unhandled SQL exception. So let's surround with try catch. And we don't just want to print to the console, right? Because if somebody's trying to visit this page and we print to the console, if they're visiting from a web browser or they're visiting from some client application, they're not going to have access to this kind of terminal down here. So what we want to do is send back an error status. So HTTP has responses, and anything in the 500 is going to be an error response. So we want to send back 500 internal server error. It's generally not good practice to send back fine-grained details about the error. So we can just do this, ctx.status, and we are just going to send back a 500 status. Just type 500 into here. And let's save that. Okay, so if we do have a list of to-dos, so there's been no SQL exception, we are just going to say ctx, and then we can say return JSON. So remember, JSON, JavaScript object notation, is the format in which we want to allow clients to communicate with our API. So that's the response they're expecting. And you're going to be very impressed by this. Javelin makes it very, very easy for us to do this. So ctx JSON, and then we can pass in to-dos. There we go. And that's going to create a JSON response for us. So that's all we have to do. We can now get all the to-dos, but how? We haven't finished yet. How do we link this to our app config? So let's go ahead and do that now. So I'm going to open up app config. So remember, this is where our roots are. And what we're going to do within our app config is the first thing we're going to do is we are going to create a new DAO, and we're going to pass that DAO into our controller, and then we're going to link the controller methods to the various roots. So let's do that. To do DAO equals new to do DAO, and let's import that. See, it doesn't let me import it here. Sometimes it does come up with the auto import. So import com.yatl.dao.to-do-DAO. So importing the to-do DAO there. The next thing we want to do is set up our to-do controller. To-do controller is going to equal new. You guys get this right now. Controller, and we're going to pass in the to-do DAO. And let's just pull in. Okay, so it's going to equal new to-do controller. And we're going to see if we can do the auto import. Nope, there we go. So let's import it up the top here. Import com.yatl.controller.to-do. Okay, so now we've passed, now we've got an instance of our to-do controller. We've passed the to-do DAO in there. The next thing we're going to want to do is reference the get all, or what did we call it? We did call it get all to-dos method as the second argument in our app.get method there. And we can do it like this. This is kind of like a modern Java feature. So we can say to-do controller get all to-dos. get all to-dos. And that is just a reference to this method. So Javelin is smart enough to know, call this method and pass in the context. Notice we don't have to even have, if we were to put those brackets, put the parentheses in, it would run the method. So it doesn't run the method, it's just a reference to it. So this will run when this route fires. So let's save that and let's just check that this does work, and we should get a list of to-dos. Currently get instance has, okay, I know what this problem is. So we need to ensure the database is initiated. We need to ensure the database is initiated. Currently it's not, so let's go ahead and go into our main class. So com.yatil main, and let's set up our database. Let's set up our database. String database path. We're going to set up a database path, and that's going to be source main resource. Let's just copy it. Let's just copy it from here. Oh, in fact, can I do this? What if I do this? If I go copy, right click, copy, and paste. No, it doesn't do it. Okay. So I'm going to right click and copy the resource path. And I'm going to do that there. Okay, so the reason why we got that error, I'll just show you quickly. So you can see in to-do DAO, we're trying to get a database connection, but we're not passing in the path. So you remember that functionality that we set up earlier. So if I just go to the database class, you can see if there is no instance and we try and get an instance without passing a path in, we throw this exception. So the application is working as expected. So the first time we set up the database, which we will do in main, we'll pass a path in, and then we have access to that instance without passing the path in. And this is a Singleton class, so there's only ever going to be one instance of it. Okay, so let's come back to main and fix this problem. String, we need to set up our URL, and we've done this before, right? Java database connection, SQLite, and then we're going to add the path, add database path, and then we just do database dot instance, and we pass in the URL there. All right, let's try this again. So hopefully we haven't got any typos or anything, and this should work now. Okay, so it's saying here, failed to bind here, address already in use. Okay, so sometimes this happens, sometimes it keeps running in the background, and if this does happen, we can just change the port to 9000. But we are getting a little bit further now. So you can change this port to whatever you want, it doesn't really matter. Okay, so now it looks like we're just getting this logging error issue. So let's see now if we can visit to-dos. And I know there's a little bit of extra work we have to do. So let's come to here, localhost, I've changed it to 9000 now. Aha, it's telling us something. So it looks like you haven't have an object mapper, or you don't have an object mapper configured. So the reason being is Javelin needs some way to map our response to JSON. It needs an object mapper, and it's telling us it needs a further dependency. So we're going to add that dependency to our pom.xml. We're going to restart, and then we should get our JSON list. So if we go to pom.xml and we add the dependency in here, save that. And I'm just going to format this quickly. Command Shift F, I think. Okay, cool. Okay, so let's stop this. So fingers crossed, we're going to have access to the port still. Come back to main, run main. Awesome. And now, awesome. So we have access to our to-do JSON response. So that's absolutely fantastic. So the reason why it's formatted for me, so if you were using something like Chrome, it wouldn't be formatted. So you have two possible options. The first option is you add, because you're going to see it like this, right? If you're using something like Chrome. So if you use either Brave or Firefox as a browser, it's going to have auto formatting for the JSON, or you can just look for a browser extension that formats JSON. There's loads available. But you can see we have our to-dos here. So now we're just going to add a little bit more functionality that allows us to filter the to-dos and get the to-dos by a single ID. Okay, so I'm back in app config and we are now going to implement the remaining functionality. So first thing we're going to do is implement this route here. And you have to bear in mind, this ID is provided by the user, so we don't want to directly use that in our SQL query. So I'm going to show you how to make a prepared statement. Now, the first thought you should be having is I need to manipulate the database in terms of getting data out. So we need to update our to-do DAO. So we need to update our to-do DAO, and we're going to set up a method, get by ID, and it's going to return just a single to-do. So let's do that now. So public to-do get by ID, and it's going to take in the ID, which is just going to be an integer, and it's going to throw, just like the method above, a SQL exception. It's going to throw a SQL exception. Okay, so the first thing we want to do is prepare our statement, and this is probably just saying the method must return a type result to do, and we're not returning to do yet. So this is how you construct a prepared statement. And it's pretty easy. We firstly just set up a string that's going to hold our statement, and we want to say select star from to-dos where ID equals just question mark. And now what this is saying is, here's a select statement, all of this bit I've written, but the question mark bit, well, that's going to be user input, and we cannot trust that, right? We can't trust that. So then we are going to ask connection, rather than just hand us back a statement here, we're going to ask it to hand us back a prepared statement, so slightly different. So prepared statement this time, and we're going to say con dot prepared statement, and we pass in our statement. We pass in our statement there. Let's see if this actually worked. So just see if we can import this. Import prepared statement. And I haven't actually said the variable name. So stmt equals con dot. And let's just see if we can use some autocomplete. There we go, prepared statement there, and statement is now passed in. Okay, so now we've got the prepared statement. We simply need to set this kind of integer here. We need to set the ID, and we do it like this. So we say statement dot set int, and we pass in the ID, or we pass in firstly 1, which is the first question mark, because we can have multiple question marks in there, multiple placeholders if you like, and we're just going to replace that with our ID. So that sets the statement up for us, and now we can pretty much just grab a result set like we did before. Result set rs equals stmt dot execute query, and let's just check if we can do this. So this is going to hand back a pointer to our result set, but there should only be one result. So I don't have to iterate across. I don't have to iterate across the entire result set. I know it's going to be there when I say rs.next. It's the first item that it's pointed to. So I can do this. I can say if rs.next, so this will return something, right? So it's not going to be false, it's going to be true. I can then set up a new to-do item. So I'm just going to grab this line here. It's exactly the same functionality. Paste that in. To-dos dot add. Okay, so I'm just going to say to-do equals. I'm not going to do that. I'm going to say, I'm going to set up a to-do up here. Oh no, actually, another way to do this. I'm simply going to return a to-do. I'm going to return a to-do. Just return a single to-do. There we go. There we go. And that there. So I'm going to return a single to-do. And now I have to say new to-do, right? So I set up a new to-do and return it. Else, in fact, I don't need an else, right? Because if this has a to-do in it, I return the to-do. Otherwise, I return null. I return null. We could throw an exception here, but let's just return null and handle this error further up the stack. So, okay, cool. So now we set up the DAO. Let's see if we can use this method in the controller to get the to-do by a ID. So let's come back up to our to-do controller. And we're going to set up a method, get to-do by ID. Get to-do by ID. And remember, all of these methods that we set up, public, are void, because they interact with the context. They don't interact with another object calling them, if that makes sense. To-do by ID, and then context, CTX. Okay, so we've got a slight challenge. We need to grab the ID out of the URL, and Javelin actually makes that really easy for us to do. Javelin makes that really easy for us to do. So we could say int ID equals integer dot parse int. Bear in mind the URL where we're getting the ID from is going to be a string, so we need to parse it. And then we say CTX, and it really is this simple, dot get param, CTX dot path, param, and that's going to be ID. And this sort of does a pattern match, right? So it's going to say anything after this / is the ID, and it's going to return that back. And I should be able to parse that there. I'm then going to grab a to-do. So to-do equals to-do, and this is going to be to-do DAO, and I'm going to ask the to-do DAO get by ID. Let's just check. Okay, yeah, to-do DAO, that's fine. Get by ID. In fact, let's just double check the to-do DAO here. Yep, it's just get by ID, and we're just going to pass in the ID. Get by ID, and we're going to pass in our ID. And what's this saying here? To-do DAO, to-do DAO. That's it there. So unhandled SQL exception. So we're going to surround this by try and catch. Surround by try and catch. We're going to try and gracefully handle this error. So we're going to say ctx.status 500 if that happens, because it's a server error, right? We now need to check if the to-do is not equal to null. And if it's not equal to null, we're just going to return the to-do. Otherwise, we're going to set the status to 404. And I'll explain more about that in a second. So if to-do not equal to null, because remember, if we don't find the to-do, we return null, right? We're going to say ctx.json and just pass back the to-do. And we do need an else statement here. In fact, no, let's put an else statement in. You could get away with not using an else statement, but I'm just going to put one in for clarity. So we ctx.status, and this isn't actually an error as such, and there's something called 404, which in HTTP means not found. So we're going to return a 404 error. It's not an internal server error, it's a 404 error. And then we can do this, ctx.result, and we can pass some information back to do not found. And there we go. So now let's tie this method in on our app config. So let's just double check the method name. We've got an error here. Okay, so I will just type this out correctly and also put quotations in. Okay, cool. So we now no longer have an error, and let's just double check the method name, get to do by ID. Let's come to our app config and let's just get rid of this. Okay, so we're now running the get to do by ID method, and let's see if we can do this. So let's stop the server from running and let's rerun it. Okay, so it's running again. Coming to my browser, localhost 8000 to-dos, endpoint to-dos not found. Okay, I think I set up a new, let me just come to main. Okay, so it's on 9000. That's an old instance of the app running. So remember, we couldn't actually run the app on 8000 earlier. So you may be on 8000. I'm going to be on port 9000. So that gives us a list of to-dos. Now if I say /1, I should see just learn Java. And I do learn Java there. If I put in a ID that doesn't exist, 100, to do not found. So that is that task done, and we've quite gracefully handled the errors, and we've also parsed the user input. So now let's do the final task, and I'm going to go back to Excalidraw just to show you what we need to do for the final task. So the final task is we need to access this query string here. So if I go to to-dos and type in status equals completed, I should just see the completed to-do. So that should just be ACE software engineering. Now you can see it fires on this route, but there's additional information. So I don't need to create a new controller method, but I do need to check in the list all controller method, this one up here, get all to-dos rather, if that query string is set. And if it is, I'm going to call a different method on the DAO. I'm going to call a different method on the DAO. Now, maybe pause the video and see if you can do that yourself. Read into the Javelin documentation and understand how to access a query string. Otherwise, I'm going to show you now. Okay, so the first thing I am going to do is set up a method in to-do-DAO that gets an ID by, gets all the to-dos by statement, by status. So it's going to be similar to list, so I'm just going to copy list and paste it, and we're going to modify list. But there's going to be a few subtle differences. Okay, so the first thing we're going to do is rename the method to get by status, and we're going to take in a Boolean status. Okay, so the first thing I need to do is prepare. Do I need to prepare a statement? Well, no, I don't actually in this case. I was thinking I do, but it can only take in true or false, so I don't need to prepare a statement in this case. So select star from to-dos, and we're just going to add on to this where completed equals plus status. And I think the rest is pretty much the same. So wasn't that easy? So now let's consider how we might handle this in the controller. So let's come back to our to-dos controller. So we don't need to add another method. So get all to-dos is going to be returned. But what we need to do is set up an if statement here to check the status. So firstly, let's grab the status out of the URL. So remember, the status is going to be in this part of the URL. This is known as a query string. And let's grab that. So we can say string status equals ctx dot query parameter. Query param, I think. Okay, so why is it not liking that? Let's see if I'm spelling it right. Query param. There we go, query param. Okay, so what query parameter do we want to grab out? Well, we want to grab out status. So it's just going to take in a string, and that's just going to be which parameter I want to grab out. Now there could be multiple parameters in here, right? Okay, so now we've got that. We want to take a look at the status. And we're going to use an else if loop here. Else if loop, else if statement. So first thing we want to do is check, is the status even set? So if we say if status equals null, let's just see if we can do this. I'm going to give something. Okay, actually no, let's just do it this way. So we're going to do a nested if loop. If status not equal to null, we can then look and see what the value of the status is. Now, you can't take a string in Java and say, does it equal complete, right? You can't do that. Does it equal active? Does it equal active? You can't do that in Java. You have to use the dot equals method. So let's do this. So if status dot equals completed, then we are going to grab our to-dos, but they're going to equal to-do DAO dot get by status, and then we're going to pass into this completed, into this. What did we say we're going to pass into here? Let's come back to our to-do DAO. I've just forgotten what we're actually going to pass in. Okay, status can either equal true or false because it's a boolean, right? True or false because it's a boolean. So we're going to pass into this completed. We're going to pass into this true because it's true if it's been completed. I got a little confused then. Okay, so then we're going to say else if, and then we can put in status dot equals, and we're just going to copy this section here. Status dot equals active, so an active to do. Then to-dos is going to equal to-do DAO dot get by status. I could say get all by status, but get by status is fine. False. So it hasn't been completed. So completed, which is a boolean, is going to be false. And finally, our final case. It's just going to be to-dos. It's just going to equal to-do DAO dot get all. To-do DAO dot get all. And that should do it. So let me just do this, save this, do a little bit of formatting. And there we go. So if the status in the URL equals completed, return all to-dos that have a status of true. Otherwise, return all to-dos that have a completed status of false. If we have active in there, if we have active in the URL. Otherwise, finally, if active and completed aren't set, then we're just going to get all of the to-dos. So let's check this out and see if it works. So come back to main, run the main. No errors so far. And now we should just see ACE Software Engineering. There we go, ACE Software Engineering. So that's what we're expecting. And let's try active. And we see just the active to-dos and not ACE Software Engineering. So we are done and we've achieved a lot. And you have to think that this is just the foundation for starting an application. And it's always the hardest bit because we're structuring everything. But now we've got this lovely modular app and it's very easy to add functionality. So say, for instance, you wanted to add more query parameters, you know how to do that, you know what parts of the application to update. And yeah, you're in a position now where you can just keep adding functionality. The next part of the tutorial, which we're doing the following week, is going to be testing this. So understanding how you can write very comprehensive tests in order to ensure all of this is working and more importantly, continues to work when we refactor the code. So thank you very much for watching. It's been a lot of fun. We've learned loads and we've made a real application. So I'm proud of you if you got this far.